What we're going to do now is see how acids react to metals. We are going to compare 6 molar acetic acid, it's right here, and that's a weak acid, to 6 molar HCl. Oh, sorry, it's a little hard to see with the glare. But 6 molar HCl, and HCl is a strong acid. So what we're going to do is we are going to use 2 test tubes. First off, we want to mark what they are. So I'm going to write, HCl for our first one. HCl, so we know what we're comparing. And on my second one, I will mark my acetic acid, which I'm just going to call it AA for acetic acid. So I have acetic acid and I have HCl. So what we're going to do now is we're going to start off by putting a little bit of, we're going to go with mossy zinc to start off with, okay? So mossy zinc looks like this. It's this lovely metal. And we're going to add a comparable amount to each test tube, just a little bit so you can see what's happening. So add a little few pieces into the acetic acid and a few over into the test tube that is marked HCl. So now you can see the zinc in the bottom of each one. So what we're going to do is we are going to add some in and then watch what happens, and I'll kind of describe what's happening as well. So if we start with the acetic acid, we're going to put this in, and immediately you start seeing some bubbling. So you can see a little bit of bubbles forming, very small, not a lot, a little bit of gas, a very strong odor, by the way. It smells very much so like vinegar, but quiet little tiny bubbles happening. If we add the 6 molar HCl, we're going to add into this one, vigorous bubbling. You can actually see the gas coming off that's forming. And right now this test tube is getting actually pretty hot. So we have a little bit of a heat change here, not a lot, and this is getting a little warmer. So as they react, they're getting warmer. The HCl bubbling vigorously, and you can actually see some of the gas escaping. There it is from the end of the test tube. Isn't that nuts? So there it goes. And our acetic acid, not a lot happening, okay, with the zinc. Little bubbles here and there, nowhere near. We're almost completely gone. So that's what's happening there. So we have HCl and acetic acid. So now, and they're both bubbling, mind you, okay? The acetic acid is still bubbling too. I'm going to try to bring this closer. It's just really small bubbles right at the top. It's probably a little harder to see, but very minuscule. You can kind of see them coming off. Nowhere near as vigorous as the HCl. Okay? Oh, sorry, it's a little vigorously bubbling. Little tiny bubbles. So the next two that we're going to do is we're going to use some magnesium. So again, we're going to take our 2 test tubes and we're going to label them. So we'll label one HCl and the other for our acetic acid. I'm just going to call it AA. And in this case, what we're going to do, I'm going to let these rest here, is we are going to use a strip of magnesium. And I've already polished this, meaning I've taken some sandpaper and taken off the edge. So we're going to just give it a little tiny piece. So we're going to cut some small pieces off. Oops. And we're going to put them in. There goes one. Here goes the other. So I have 2 pieces in. I'm going to orient them the right way. And so I have HCl here. And, sorry, hope that you can see it. HCl here and the acetic acid in this one. And this is with magnesium ribbon. So let's add that acetic acid first. And you can immediately see the bubbling. It's actually making the metal move. Again, we still have that strong vinegar odor, but there's our metal just bubbling around and moving. Definitely reacting a lot faster than it did with the zinc. Now if we add in some 6 molar HCl, same amount, I don't know if you can hear that, but holy smokes. So we can see the gas coming out of the top of the test tube in this case. And if you feel the bottom, this is really hot to the touch. It is not comfortable to hold, that's why I'm holding up here, but touching the bottom is actually really hot. Same with the acetic acid, not so much. I can keep my finger on here longer, but right now I can only, that actually hurt. You can only touch it for a little bit before it actually gets really hot. So here we have again our 6 molar acetic acid, and then our 6 molar HCl. If we're looking at our HCl, it's all bubbles. I hate to tell you, for the most part, that piece of metal is almost gone. And then if we're looking over here, we still have our metal strip. Again, hot, but not nearly as hot. Bubbling vigorously, just nowhere near as vigorously as the 6 molar HCl. So the strength of the acid does matter. And that's where we're going to stop with that one, okay? So we've now compared what happened with magnesium and with zinc, both with our overall our vinegar or our acetic acid and our 6 molar HCl as well. In this part, we're going to compare the strength of the acids as they react. So we're going to compare 6 molar, 3 molar, and 0.1 molar. We're going to start off with acetic acid first. That's the weak acid. And we're going to react them with magnesium because that was the metal that was the most reactive that we've seen. So let's go and we'll start from highest to lowest. So we're going to add a little bit of the 6 molar acetic acid into this and see how it reacts. So as you can see, it's starting to move. It's a very strong vinegar smell, but you can see the bubbles and you can see a little bit of the gas forming, and the bottom is actually getting hot. So while that's moving, we're going to go quickly, and you can now see what's happening with the 3 molar acetic acid. So with 3 molar, we'll add that right next to it. Again, you're bubbling. It's getting warm, nowhere near as vigorously, as the other one. And then we're going to do 0.1. So here's 6, here's 3, and now we're going to have 0.1. Not much is happening with the 0.1 molar. So very, very small bubbling, very vigorous bubbling. This is actually getting very hot to the touch. Again, similar amount, but not as vigorous, and then very, very little. So the strength of the acid does matter. The stronger the acid, the hotter it gets, and the faster it reacts with the metal, the more vigorous the gas formation and the bubbles you see. The less strong it is, and the lower the molarity, the less of the reaction you're seeing is taking longer. So this is quite cool to the touch, very limited bubbles versus very hot, and now the metal is almost gone here. So we saw what happened with the acetic acid. We're going to do the same thing now, looking at what's going to happen with 6 molar, 3 molar versus 0.1 molar. But now we're going to compare it with HCl, and we're still going to use our magnesium because that was the metal that reacted the most. So hopefully I'll hold them down here so you can see them, and we'll go. We're going to add our 6 molar first. Again, you can hear it, you can see it. Hopefully it's getting very hot actually. Now we're going to do our 3 molar, not as vigorous as the 6 molar, and then we'll add our 0.1. Still definitely reacting more than the acetic acid did, but again very slowly. So 6 molar the most. This is actually really hot. Then we have our 3 molar, again hot and vigorous as well, and 0.1, not much is happening. So I am actually going to move these to the test tube rack now because they are getting uncomfortable to handle. It is that much heat. So there goes our 0.1, our 3 molar, oops, sorry, didn't mean to hit that on you, and our 6 molar. So the one that is going the most is 6, then 0.3, then 3, and then 0.1. This is the extension on part C where we're going to look and check the pH of solutions. So in front of you we have HCl, our acetic acid, NaOH, NH3, okay, and all of those are 0.01 molar. Then we have vinegar, lemon juice, household ammonia, in this case we used Windex, and our detergent solution, which we just used a lovely coconut hand soap. So as we're going through, we're going to add our universal indicator, and then I want you to compare that to what you see on that sheet that's posted. So let's go with our HCl first. We're going to add a couple drops in, and as you can see, that green turned into a dark, kind of this bright colored red. Okay, there it is. Nice deep dark red. Let's try the acetic acid. Here we are, a red too, but we're a little lighter. Now NaOH. 2 drops in. We are a nice, really dark purple color. So again, that's different, but NaOH makes sense, that's the base. Let's do some NH3. Add a couple drops in. And we are a green, almost like a tealish color. So not the purple, but a green. So again, if we're just going to review those acids and bases, HCl, then we have our acetic acid, and then our NaOH. So if we're going to go with vinegar, a nice red color, very similar to the acetic acid. Makes sense because vinegar's main component is acetic acid. And then we have lemon juice. That's this cloudy one, freshly squeezed from a lemon. And again, we're seeing a dark red color. So there's that red. Nice deep dark red. There it is compared to vinegar. It's definitely a darker shade. And if we're looking at ammonia, it's a little hard, it's a blue solution to begin with, but let's add some ammonia in, our universal indicator in. I'm going to mix this to our ammonia, and we have a purple color. Ammonia is a base, has that slippery soapy feel, and here we are, a purple as compared to NaOH. This one seems a little more on the blue side. This one is more of like a lilac color. Again, NH3 is still this green color. Now if we try the detergent solution, that is our hand soap. Put a few drops in. And we're going to mix this up. Our hand soap, surprisingly, is a little orange. This is part D when we're looking at the pH of salt solutions. We have various salt solutions set up in test tubes, so we're going to look at, for all of them are going to be 0.1 molar, but we're going to compare NaCl, Na2CO3, Na3PO4, NH4Cl, and AlCl3. And we're going to use what we call a universal indicator, which is a liquid solution that will change color. And you can compare this to the little picture of the universal indicator that I have listed in the lab folder. So we're going to add just a couple drops of the indicator, which starts off as green, and see what happens to the color. So we're going to do NaCl first. Here's our NaCl. We're going to add our couple drops in of our universal indicator. And then we're going to mix it to see what color it turns. So it started off green, but it is really turning like this yellow color, okay? Again, here's the indicator in so you can see. So we have a yellow color, light yellow. If we're now looking at Na2CO3, we'll add a few drops in. Look at that, a nice purple color. Okay. So you have a purple, almost like a lavender, a little lilac. If we're looking at Na3PO4, we're going to add our couple drops in. Take a second to mix in. And we have red. This orange-red color. There it is. Now we're going to add NH4Cl. We'll add our few drops in. We have an orange. Nice carrot orange. And AlCl3. We have that red. So we're going to review here. NaCl. It's got this yellow color. When we added the green indicator, it turned yellow. Na2CO3 is purple. Na3PO4 is kind of this orangey red. NH4Cl is definitely an orange, not so much red. And then AlCl3 is a deep dark red. So there they are for you. Those are the pHs of the salts. This is part E, where we're going to react a bunch of different salt mixtures. So the first thing I want to do is go over what they look like by themselves, and then we're going to react them together and see what forms. So we are using 0.1 molar for our concentration for all of these. So they're all the same molarity. But the first one is FeCl3. This is kind of a little bit of a slurry, but it is an orange color, okay? So iron gives us this orange color, iron chloride. Then we have our cobalt, COCl2. This would be solution 2. It's a light pink to start with on its own. Solution 3 is clear. That's Na2CO3. And then solution 4 is CuSO4, and the copper gives it a nice light blue color. Solution 5 is Na3PO4. That's a clear solution to start with. And solution 6 is nickel chloride, and that has a light green tint to it. Very, very light green, NiCl2. So the first set of reactions, if you're following along with your report sheet, is what it asks us to do is to transfer half of solution 2 into test tubes of solution 1. So we're going to mix FeCl3 and COCl2. So we're going to take half of solution 2 and pour it into solution 1. So here's 1, this orange, here's 2 is pink. We're going to mix in half, and we're going to see what happens. We don't really see a change at all. It's still this orange kind of slurry. No change. Now, if we're looking at letter B, it asks us to transfer half of solution 3 into the remainder of test tube number 2. So now we're going to mix COCl2 with Na2CO3. So we're going to take half of this and put it in here. So we're just going to go with half. Oh, and look at that. We did have a nice change. We went from pink to a purple. And if you can kind of tell and see, it's a purple solid as all these little pieces of solid. So we have a precipitate coming out, but it's a nice purple color, and it's chunky. Okay. So we went to a really cool purple. Purple with a solid. Now if we're doing number C, or letter C, we're going to transfer half of solution 4 into test tube 3. So now we're mixing Na2CO3 with CuSO4. So we're going to pour half of this into here and see what happens. So we'll pour in. And here we went from clear to a bright blue. And it's brighter than what we started with, okay? And it's a solid. So we formed, again, if you're looking, there's those little blue solid chunks. We formed a blue solid precipitate, and it's a bright blue. Very similar to the precipitate we saw with the cobalt, except this one was purple. So a bright blue solid. Now if we are on letter D, it asks us to transfer half of solution 5 into the remainder of test tube 4. So here's 5, it's this, 4, so CuSO4. So we're going to mix in Na3PO4 to CuSO4 and see if anything happens. So we're going to pour half in. And realistically, nothing happened here. There's no solid formation. Color still seems the same. Nothing really. Okay. So now that leaves us with the last one, which is E, and it asks us to transfer half of the nickel chloride into our Na3PO4. So we're going to add our light green into this and see what happens. And when we add, again, no real reaction, still stays that green color. Similar to this, just an increased volume.